If you're getting ready to start your spray season, you want to make sure that you're going to be applying the right rate. If you put on too much, you run the risk of injuring your crop and wasting your product. If you put on too little, you might not get the pest control that you want. Hi, I'm Sally Raymond. I'm an educator with University of Minnesota Extension, specifically the Pesticide Safety and Environmental Education Program. And today we're going to be talking about sprayer calibration, the tools that you need, and how to get set up before you start your season. So I've got Dave out here helping me today. Dave, do you want to introduce yourself?
Sure. I'm Dave Nicolai with the University of Minnesota. I'm an extension educator in field crops, and I'm here today, Sally, to help us in terms of our calibration of a sprayer.
Calibration sounds complicated, but we're just going to start with the basics. So what are the tools that we'll need to get started?
Well, Sally, there are very simple tools that we really need to start with our calibration procedures. They are a measuring tape so that we can measure the distance between our nozzle tips. We are using a land wheel today to measure our distance that we're going to be driving the sprayer. We have personal protective equipment, we have a measuring device, and we're using flags to measure that distance in terms of what we're driving.
When we're talking about calibration and figuring out our rate, we're talking about gallons per acre or our rate of application. So what do we actually need to be measuring today in order to figure that out?
Well, there are really three things. One is nozzle pressure, the other is the distance between the nozzle tips, and finally the output on individual nozzles.
So let's talk about those different factors that go into calibration for a minute. So how does speed impact your rate?
Well, speed impacts the rate in terms of if you increase it, then you're going to be decreasing the coverage area of the area that you're actually spraying itself. If you use a different system, such as a pulse width modulation or PWM, in those situations they account for variation in terms of speed. They also make the droplet size much more uniform. But keep in mind, if you are using a conventional system, you want to try to make your speed as consistent as possible and also use the same pressure across the field area, such as 40 psi or 40 pounds per square inch, in order to get the most uniform coverage.
We also talk about how important nozzles are. So how does a nozzle factor into calibration?
Well, nozzles control the flow rate of an individual tip, and that factors into the actual coverage that we're getting across the field. Nozzles control how much pesticide comes out, how it spreads, and what size the droplets are. There are two factors to consider. First is the nozzle flow rate, and that's influenced by the size of the orifice or the nozzle opening, the nozzle pressure, and finally by the density of the spray liquid itself. The second aspect is the type of nozzle. Some common nozzle types range from a flat fan to a drift-reducing nozzle. Your job, the target pest, and product label will guide you to which nozzle to use.
So it's definitely a lot to think about. Now that we've talked about some of the basics of calibration, let's talk about how we're actually going to do it here today. Dave, what do we need to think about when we're setting up our sprayer for calibration?
In a sprayer situation, you want to make sure that your sprayer is clean, that there's no pesticide residue in or around the sprayer. You fill the spray tank half with water, and you set the pressure at 40 psi in order to get the best calibration. It's recommended that you consider goggles for eye protection as well as gloves for hand protection.
So today we're using the ounce calibration method, which takes some of the math out of it for you. The first thing we're going to need to know is our nozzle spacing.
Well, for this particular sprayer, we're going to measure the distance between one nozzle body to the most adjacent nozzle body. In this case, this sprayer is 15 inches.
Great. So now we've got our nozzle spacing of 15 inches. We can look at our handy-dandy chart here and see that with a nozzle spacing of 15 inches, our test course should be marked for 272 feet.
We're going to be using a flag to mark the starting point for our calibration run with our tractor and sprayer.
Then we'll stick our second flag right here.
We're going to be operating the tractor and sprayer over the test path that we have a measured distance in order to determine the accurate ground speed. That's because typically a tractor speedometer always isn't an accurate situation that we can use for measuring speed. So that's why we've chosen this ground path where we're actually recording the amount of time it takes to go from one flag to the next. We will drive the path for the tractor and the sprayer 3 times, and then we will average those speeds in terms of getting the average calculated speed for the tractor and sprayer in the field.
So now that we've timed it, our average time was 35 seconds. So how are we going to figure out how much is coming out of each nozzle?
Well, Sally, we're going to park the sprayer and we're going to run it at 40 psi, proper pressure for these nozzle tips, and we're going to collect for the same amount of time that we did the distance in terms of our calibration. After measuring the output on this individual nozzle, we're approximately 15 ounces in terms of the amount of time. That's equivalent to 15 gallons per acre. One of the things that we recommend operators do is to check for uniformity in terms of variability between spray tip nozzles. Ideally, when we measure from spray tip to spray tip, we're trying to look for situations where our nozzle tips are within 10% of each other in terms of variability. Another alternative to measure gallons per minute is the use of electronic calculators. This is one such device from Spot On that actually can measure the gallons per minute of individual tips when you want to compare uniformity of nozzles across the boom.
Let's take a moment to review. Your first step is to measure your nozzle spacing, then measure your test course. Third, you'll drive your test course and time it. Next, you'll collect water from one nozzle for the amount of time that it took you to drive your test course, and then that amount of ounces collected is your gallons per acre. So we know that we need to calibrate at the beginning of the year when we first start our spray season to get ready. But when do we need to recalibrate during the season?
If you're swapping out nozzle tips or recalibrating the sprayer because you indicated that you needed a mechanical item to be replaced, such as a spray pump, etc., then definitely I would recommend recalibration for that particular sprayer.
Is there any other sign of a problem with your rate that you would recommend people pay attention to?
In your normal spray operation, if you end up spraying more acres than intended or less acres than intended, or the spray tank volume is changing more than you intended it to be, certainly you would want to recalibrate the sprayer at that point in time before you go to the next load and spray again in terms of that recommended output.
Thank you so much for your help today. It was fun.
Thank you, Sally.
Now you're ready to spray with confidence. Calibrate early and often, and remember that putting down the right rate gives you your best chance at controlling your pests.